Hi everyone, Will from Foligram here. In this tutorial video, we're just going to look at how to troubleshoot common marker placement issues. We mentioned this in the last tutorial on locating models, but this will give you a practical example of what it looks like if you have multiple markers in your Rhino model and those markers aren't correctly located in space. I'll also show you how to print markers, generate multiple markers if you need to, and give you a few tips for handling physical markers. So in the last video we had one single marker set up. I showed you how to snap onto that marker. If you want to actually print this QR code, I already had mine printed out from an earlier demo. You can print all markers in your model using the XR marker command and then clicking print all. What that'll do is it'll open the Foligram web app with a UI for generating markers, and it'll automatically populate that with the labels of any markers that you have in your model. So if we wanted to make new markers here, let's say we wanted to print off a couple of them, you can enter in all the labels that you want, hit print, and that's just going to create a custom print preview. And you can save that as a PDF or print it directly to your printer. Now, some notes on printing these out. So you can print markers at any scale. That's it's going to work fine. They can be on A0, on A5, what scale doesn't matter. But we typically try to print them off on A4. We find that's a pretty good trade-off between the markers being small enough to be convenient to transport and handle and print, and large enough to relatively easily detect. Larger markers will detect more easily, but they won't necessarily be more precise. And this is because while your phone or HoloLens mixed reality device might be able to detect a large marker from further away, it'll be the same number of pixels in the camera which are detecting that marker position, and therefore if the marker is detected further away, you can expect there to be more error in the estimated depth and location of that marker from the camera. So we find that when you print markers on A4 like this, they typically scan at around and about arm's length fine, and at about arm's length from the camera, they typically scan with about 1 millimeter of error. It's very precise. For placement, when we're using multiple markers, it is only this corner point of the QR code which is used. If you're using one single marker, we also use the orientation of the code. Now, this Foligram's tracking is optimized to make the detection of this corner point as precise as possible. It's the most reliably tracked position on the code. The orientation of the code is not going to be as accurate as the detection of that single corner point. So you might find that if you locate models with just a single marker and then you walk, say, a couple of meters away from that marker, you'll begin to notice that the model maybe isn't as accurately rotated as you would like, and this this is a great example of why you might want to use 2 or more markers to locate a model, because when you use multiple markers, what Foligram does is it uses the tracked coordinates to locate the model, and it'll set the orientation by interpolating between multiple marker positions. So if you've got 2 markers, what it's going to do is it'll position the model with these corner points, and it'll rotate your model so that the coordinate space in Rhino matches the coordinate space of your physical markers. And we're going to see that in a demo in a second. When you print off these markers, you can trim the bottom of the sheet off. These are just instructions for how to use the marker, so you can cut the sheet along this black line here. And if you're wanting to locate this marker against an edge, so say you want to push the marker up against a wall or something like that, you can also fold the corner of the printed sheet over along this corner indicated by the blue triangle. So you can fold the sheet back to this corner here, and that'll let you push that corner point right up against a hard surface. In general, try to keep around 10 mil at least of white space around the QR code. Don't trim your printed page all the way back to the black on the QR code. That'll create issues with tracking and detection. So leave lots of white space around the marker. And the last thing to remember is to try to keep this printed marker page as flat as possible. If the page isn't flat, if it's deformed or it's got creases in it, or it's not sitting flat on a surface, that's going to impact the detected orientation of the code, and it'll also impact the detected depth of the code, and in some cases might even impact how well the code tracks. So make sure you keep your marker as flat as possible. Okay, back into Rhino. So let's say we want to do we want to place this model not with just one code, but with two codes. So I'm going to use the XR marker command to make another marker at 1000. I'm going to call that F4 because I already have these two markers down on the floor. So we'll set up our mobile device, connect to this session. Just give it a second to detect that QR code. Tap to place our model somewhere, doesn't really matter where for now. Okay, and we'll go and try and snap it onto these markers on the floor. Okay, it's detected one. Detected two. Okay, so now our model is being located with two markers rather than just a single marker. And you'll notice hopefully that model seems pretty stable. It's not moving around too much as we move the phone. That's what you want. Now, if I move one of these markers to a different position so that they're now no longer 1 meter apart, and rescan the codes, scan that one, scan that one. What we should notice is as we move the phone around, we can see this model moving and rotating. You can see that crosshair moving, trying to keep that model in the right place. So you can see it moving relative to the QR code. So instead of that hologram remaining fixed relative to that QR code, physical QR code in exactly the right spot, you can see that the green box is actually drifting around and appearing to move quite a lot from its physical location. So in this case, that isn't actually caused by a drift in the space. It's caused by the positions of these two markers. Rather than being exactly 1 meter apart, as I specified in my Rhino model, these codes were not located accurately. They're less than 1 meter apart, and Hologram is having to correct for that by moving the position of the hologram to try and make sure that as that phone moves around, the relative distance between these markers remains the same. So if you're experiencing large amounts of drift like that, make sure that you've located your models as accurately as, or your markers as accurately as possible. And generally speaking, maybe try just using a single marker or just two markers set out with a tape measure, because those are very, very easy to set out. It's hard to make mistakes in where they're located before you introduce more markers.